Hello and welcome. Happy New Year, everyone. Hopefully, this new year will be beyond your wildest dreams. Bit of a funny Apache Kafka shirt that I got off the Confluent folks. Anyway, so just thought I would say a quick hello at the start of the meetup and just welcome you back to the new year. Hopefully, you've had a really restful break. Um, what a year 2021 turned out to be. It was huge for me personally, but also how good was Starter Bytes 2021? I think the lineup was incredible. Just our keynotes of Bar Moses, Maxime Beauchamp, and Simon O'Toole just blew me away, let alone the rest of the speakers that we had. Hopefully, you've had a little bit of a chance to catch up on some of those talks on our YouTube channel. They were just sensational. I learned so much off all of you and all of our speakers. Really grateful for the experience of being involved, and I think I can speak on behalf of the organizing committee that we had a lot of fun putting it together, even though it was kind of stressful switching again from in person to an online meetup conference. Sorry, but hopefully, with a bit of luck this year and our friendly pandemic will allow us to get back to meetups and conferences in person. Um, Not only we're hoping to bring you a long-awaited in-person conference, but also we're working in the background to put together a hackathon so that you can get some experience with all the latest and greatest data engineering tools, help you to sort of build up your experience, grow out your career. So hopefully that will be a welcome thing for you all. So that's basically a bit of a taste of what we've got coming up this year. I wanted to again sort of thank all of our awesome sponsors for the DataEng Bytes conference last year. They were incredible with their support and understanding of having to switch from online to or from in person to online. So Snowflake, Fivetran, Databricks, Microsoft Azure, AWS, Imply, Versor, DBT Labs, ThoughtWorks, High Touch, Microsoft Reactor, Yao Conferences, and my little old company, Cloud Shuttle. So, thank you all to our amazing sponsors. This community wouldn't exist, or we wouldn't be able to put on these amazing conferences and awesome events without the help of our sponsors. If you'd like to sponsor, be a part of 2022, just reach out. Always more than welcome to bring on sort of more sponsors, especially if you're really keen to help support the data engineering community here in Australia and New Zealand. Okay, announcements out of the way. We want to just dive straight into our awesome meetup this month. Always on the lookout for new speakers as well, folks. So we'll do another call out at the end of the meetup. But up first, we've got Paul Brebner. He's the technology evangelist at Instaclustr. He'll be taking us through building and scaling robust zero code IoT streaming data pipelines with open source technologies. I think that sounds amazing. I'm sure we're going to learn a bunch. Kafka Connect, Camel Kafka Connector, supplemented with Prometheus and Grafana for monitoring, and Open Distro for Elasticsearch and Cabana, and also PostgreSQL and Apache Superset. So I think it's pretty much a full end-to-end data engineering setup that he's going to be taking us through. Paul's got an amazing career in open source and working for government, including like CSIRO and things like that. So and he's got a master's of machine learning and a bachelor of computer science and philosophy. So definitely a smart chap. So really looking forward to his talk today. And then afterwards, you'll have to sit through me rambling on about a Aws Reinvent Recap. I'm going to keep it focused on what's important for data engineers. So I'm not going to go through absolutely everything that was announced at reInvent, but hopefully, if you're on the AWS cloud, you'll be able to take some cool learnings from it, and perhaps might motivate you to give a few of these new services a try, because there are some amazing announcements, especially in my two sort of passion areas of serverless and data engineering. I think there's been a bit of a confluence of the two, a merging of the two together, which is really awesome to hear. But without further ado, I will add Sir Paul Brebner to the live stream. Is this your second or third meetup talk at the Data Engineering Meetup?
I've lost count, to be honest. So
yeah,
I know some of them were in person, and others I have given virtually from Canberra as well. So
yeah, it might have been even more. So that's really cool. I might just add your slides to the screen. You'll need to full screen it. That didn't work.
Okay.
I'm gonna stop sharing and reshare your slides.
That may have been
the technical issues at the first meetup back for the year.
Yeah. Okay. Let's try that. No. That's sharing the window again. Is that going to work or not?
Yep, that looks like it's working. So I'm going to drop off and let you take it away.
Okay, thanks, Peter. Thanks for the introduction and for the invitation as well to speak. I, in fact, kick off the Data Engineering Sydney meetup for the year. That's quite a privilege. So thanks, everyone. Even though I'm based in Canberra, I sort of have a bit of a connection with Sydney still. So my younger son is there these days studying. So it's nice to be part of the community even at a distance. So this is a talk that sort of has evolved over the last perhaps 18 months, and I gave it last at ApacheCon last year, which feels like a bit of a time ago now. So hopefully I can remember all the interesting points and all the fun stuff. So let's see. So Instaclustr, I'm the technology evangelist at Instaclustr. We're pretty much a global company now. We've got customers and staff all over the place. It's basically a managed platform for big data, open source software with lots of different use cases, lots of different technologies, and on multiple different platforms with lots of enterprise features that people actually need to be able to run enterprise systems reliably and at scale. So this talk will focus on one particular use case, IoT use case. We're looking at Kafka and Kafka Connect as sort of the common ingestion integration technology, and then two alternative paths really for the pipeline. Option one is using Elasticsearch, and eventually we switched to OpenSearch plus Cabana for the target systems. And then option two was a more recent innovation that we tried out using Postgres and Apache Superset. So that's what we're going to be looking at. So the question of pipes, pipes can be puzzling perhaps. Here are some pipes that I took a photo of when I was at ApacheCon a long time ago now in Berlin in 2019, I think it was. I wondered whether they were perhaps piping beer around the city. I had heard that they did use pipes for beer. Some pipes can be pretty long and boring, just disappearing off into the distance. Others can be more fun or potentially dangerous. But pipes and integration in general can be quite complicated, and sometimes things, if they go wrong, can blow up. This is actually a rocket engine, all the pipes for a rocket. So I guess the question I wanted to ask myself, initially at least, was, is building a robust, scalable, zero-code, open-source data pipeline a pipe dream or not? Let's find out. So this is what we're going to cover in this talk, the story, the options, some monitoring, some scalability results, and an attempt at actually comparing and contrasting the alternatives at the end. So what's the story? Well, unfortunately, the COVID-19 has been sort of the thing that's been in the back of everyone's minds for several years now. But at the start, I think it was, of 2020, the American CDC built a Kafka COVID-19 specific pipeline in under 30 days, which was reported in one of the Kafka conferences, and it was quite an interesting story at the time. And some of our consultants in the US picked up on that story and actually built a sort of an integration demo using some different data, some public climate change data via REST connectors running on a Docker container. So I thought I'd extend that idea and use streaming REST public data sources and try and deploy it on our Instaclustr managed platform. So the problem was that we needed some public streaming REST APIs with easy to use JSON data, complete data available, and some sort of an interesting domain. And at the time, we didn't want one that was too political or apocalyptic, for example, COVID-19 or climate change. Was this an impossible requirement? Well, at the time, we found a solution which was to use some tidal data from the USA National Oceanic and Atmospheric Administration, or NOAA for short. So tides are something that we all sort of have some experience with and knowledge of. Basically, a lunar day is slightly longer than an Earth day. It's 24 hours and 50 minutes. So that's the period between the maximum tides, which explains why tides change across time as well. So this looked like sort of interesting data. There's quite a lot of information on the NOAA website. They actually have useful things like maps, so you can see where all the tidal sensors are located, and it's focused primarily on the USA mainland, but they do have a few sensors available, for example, quite close to Australia in the Pacific, where there are US outposts, I guess you'd call them. So you can actually drill down on their maps and see what's at a particular location. There's a particular sensor on the north coast of Alaska, and you can click on that and have a look down, find the name. It's at Prudhoe Bay. You can get some summary data. You can look at a picture of what's actually there. You can look at some graphs to see what the water levels were doing over time. Also some other sort of background weather data as well. So it looks sort of interesting. And what's more, there's a well-documented API available. So they've put a lot of thought into the design of the API. There are lots of different things you can do with it to query data. So here is an example of a REST query. Basically, you specify a station ID, the data type and datum that you want. So I was interested in water level and the mean sea level. And then you can request the latest data point and the format of the data you want. In this case, I wanted some JSON data to come back again. So there's the call, and there's an example of the data that we're going to be now working with for the rest of this example. It's got two fields, a metadata field and a data field. And it's in JSON, and it's relatively easy to understand. So let's start our pipeline using the NOAA REST API for the data sources. So basically what's happening is there's a REST call that's querying the sensor and returning the data. It's the latest data point available. So what else do we need to build the pipeline? Well, Kafka Connect is a good option. It's the common technology we use for both alternative paths. It's a distributed solution to integrate Kafka with other heterogeneous data sources and stores. You need to have some connectors, either in source or sync flavors, to handle the details of the particular integrations. And why would you use it? Well, it claims to provide zero code integration. It provides high availability in terms of having a robust cluster architecture, and you can have elastic scaling independent of the actual Kafka cluster as well, which is quite a good thing as it turns out. So here's the sort of the overall look at the option one, where we used Elasticsearch and Cabana as the sync systems. Elasticsearch is a scalable method of search of indexed documents. Cabana is the tool that provides for visualization. Initially, when I started out this project, I was using Open Distro for Elasticsearch, but we did switch eventually to OpenSearch later on. So using Instaclustr, it's very easy to spin up a cluster of a required size and location and other add-ons and things that you might want. So here's just a screenshot showing how you provision Kafka and the Kafka Connect clusters, and they know about each other if you set them up that way, so they can talk to each other. So now we end up with the Kafka and Kafka Connect clusters all working together nicely. So the next problem was to find a REST connector So this was relatively straightforward. There was one available. The way that we bring foreign connectors, if you like, into our managed cluster is, first of all, you have to deploy it to an S3 bucket on Amazon, tell the Connect cluster which bucket to look in, and then configure the connector and then run it. And that enables you to bring in arbitrary open source connectors or connectors that you might have a license for to run in a cloud environment. So that all worked smoothly according to our support instructions. Okay. So in terms of trying to configure the connector, here's an example of the configuration. This is where it starts to get a bit more complicated and messy. Here's the REST source connector configuration, including connector name, the class, URL, and the topic that we want the connector to write the data into Kafka to. So I've highlighted some of the more important things that you have to set for that example. So once the connector is running, which our console will report that it's up and running once you start it, it polls every 10 minutes. It writes the result to a Kafka topic. And I picked 5 sort of sensors at random to use for this example. So there are 5 connector instances running in the Kafka Connect cluster. So now we've actually got Tidal data coming into the Kafka Tides topic. So that's successful. What do we do next? Well, we've got to have somewhere to send the data to. So we provision an Elasticsearch and Cabana cluster. And then we configure the default Elasticsearch sync connector. And now in our managed Kafka Connect, we actually do provide a default one. So that was the one I started out with. We configure it then to send the data to Elasticsearch. Here's an example of the configuration for the sync connector. Again, you have to provide details like the name, the class, index name, and the topic to get the data from. In this example, the index is just created with default mappings if the index doesn't exist, which it didn't when I started out. So we just started out with the default index looking like that. And great, it's all working well, sort of. So the whole pipeline end-to-end works. The Tide data arrives in the Tides index. Now, it turns out that the Noah data is JSON, which is what we actually wanted anyway. And Elasticsearch is JSON native, so it understands JSON data reasonably well by default. But in the default index mappings, everything is just a string. So it turns out to graph different types of data, you actually need custom mapping. So for example, to graph as a time series, you need a custom mapping at that point. And here's an example of custom mapping. You need to specify the data types of some of the fields in the JSON data. So we're saying basically that T is date, V is a double, and name is a keyword. And that gives Elasticsearch and Cabana in particular really enough information then to do something sensible with the graphs. Reindexing. So every time you change an Elasticsearch index mapping, you have to delete the index and index all the data again. But where does the data come from? Well, there's 2 options. Using a Kafka sync connector, the data is really already in the Kafka topic, so you can just replay it. That's quite cool. Or you can use the Elasticsearch reindex operation as well. So that's the hard part over. Now let's have a look at the data. You just start Cabana with a single click in a managed service, so that's really straightforward. And it comes up with the Cabana homepage. Takes a bit of time to get used to Cabana. It's quite a powerful tool. But there's always a few steps to turn the data into something you can actually graph. So there's the visualization steps. For this example were that we had to create an index pattern, which basically gets the data from Elasticsearch, create the visualization to create the graph type, and then configure the graph settings to display the data correctly on the selected graph type. So this is what you end up with if all those things succeeded. We've got a time series graph and time on the x-axis versus average over a 30-minute period of the tide level for the 5 sample stations. So that shows that we've got real tidal data coming in. It's got a waveform that you can look at. There's a period there. So it looks like we're actually getting some useful data, which is pretty cool. But what can we see in particular? Well, I mentioned before that the lunar day is 24 hours and 50 minutes long, and you can see that quite easily on that graph. Between the two peaks is 24 hours and 50 minutes, which is great. The other slightly interesting thing, which I wasn't perhaps expecting, was that you can also see that there's a difference in the tidal range between the different locations. So some of the locations actually have very big ranges of tidal data. Neo Bay, for example, is the one I've highlighted there. That's quite a few meters every day. It goes up and down, whereas compared to other locations, which have like, sort of only maybe less than half a meter of tidal range, so it's quite obvious. It's quite interesting. So it turns out that tide range varies depending on a whole bunch of things, including the moon, sun, local geography, and weather, not surprisingly. So here's a map actually of worldwide sort of hotspots for tidal range. Neo Bay in the US is actually near one of the big tidal range peaks in the US. But if you look at Australia, there's actually a black spot on the Australian coast as well. Australia's biggest tide is actually there, where the arrow is, which is actually quite a popular tourist resort or location, evidently, in Australia. It's the horizontal waterfalls in the Kimberley region, so that's quite interesting, evidently. The water basically rushes through a very narrow gap because of the huge tidal variation there. So I thought, well, next let's try and actually show the sensor locations on a map to understand which locations have the big tidal ranges. And there's my first attempt at a map. There is nothing shown on the map, unfortunately, and this is because there are no geo points in the data. So Cabana doesn't understand raw lat long data. It needs special data called geo points in order to display them on a map. So again, there's some steps required to turn my data into data that can be mapped easily. Basically, what I did was add an Elasticsearch ingest pipeline to pre-process the documents before they are indexed. And then, of course, you need to re-index the data all over again. So the steps were to add a geopoint field for index mapping, create Elasticsearch ingest pipeline, and then add this as a default ingest pipeline to the index. So here we have a bit more detailed. This is adding the new location field with the geopoint data type to the mapping and the index. Then you create the new ingest pipeline to create the new geopoint string from the existing lat long fields, and then setting this as the default pipeline to the index. And if that all worked, then now we've got a pipeline transforming the raw data and adding geopoint location data in Elasticsearch. And then the final steps to actually visualize that reusing an existing index pattern. You can create the visualization and configure the graph settings as follows to display the data correctly. And with a bit of luck, you end up with a map that would look a bit like this. So this shows sensor locations and just sort of a random value that I picked, which is the minimum value of the tide over a period of a week. So the data can be graphed on a map okay. There's a few nice features of Cabana mapping. You can actually add your own custom web map service layers, which provide a lot more detail. Although this particular example that I found is a bit strange in that it is very USA mainland specific. There's a country missing, I think, to the north of the US at that point. But what can go wrong? Well, quite a few things. JSON error messages for a start. So the first problem is that the REST call can return JSON error messages, which aren't really treated as an error as such. They're just data. So this data is just sent to the tides topic and eventually to the Elastic index. You can also get HTTP errors, as it turned out. These weren't as common, but after a few days, I started getting a few of these. So the REST call can actually return an HTTP formatted error message. And again, that's not really recognized as an error. And that is sent through to the tides topic. And then the Elastic Sync connector tries to read the HTTP error message, and not surprisingly, it fails. And it fails to the fail state, which means the Kafka connector is no longer running, which means the data isn't getting moved through the system. Luckily, the exceptions are viewable in the Kafka Connect logs topic, so I detected that something was going wrong. I was a bit surprised initially by this. My previous playing around with the Kafka Connect framework in a sort of artificial test environment indicated that Kafka Connect automatically restarts the work as if they are killed. So pretty robust as far as that goes. But if the connectors themselves actually enter a fail state, the Connect framework doesn't restart them. So that requires manual intervention at that point. So what sort of solutions did I look at? Well, the best one is if connectors support a particular KIP error handling in Connect, then you can configure them in theory to ignore input errors. And the errors are then sent to a dead letter topic. Yeah, so that's certainly one possible solution. So the next question then was, where can we find connectors with more robust error handling capabilities? And oddly enough, in the Australian outback, it's potentially one source of such connectors. There's another Apache project called Apache Camel that has a very large number of Kafka connectors, 346 at the last count when I first wrote this talk, far more than any other pool of open source connectors that I could find at the time. Apache Camel itself is a 10-year-old project for integration. It's quite mature. It has a lot of components to integrate everything with everything. But I was quite curious about how did they suddenly get so many Kafka connectors as well. So how did Kafka and Camel get together? Well, it turned out that there was a new subproject, the Camel Kafka Connector subproject. Basically, it enables Camel components to be used as Kafka Connect connectors. How does it do this? Well, basically, it uses automatic generation of connectors from the Camel components. You end up with source and or sync connectors, depending on the nature of the Camel components themselves. The Kafka connector configurations contain a mixture of Kafka Connect and Camel configuration stuff, which is a bit tricky to get your head around initially. And you need to read both the documentation for the Camel component and the Camel Kafka connector itself. And there's a fair amount of trial and error and testing to find all the required fields and to get them working correctly. So I took one for a test ride. How did it go? Here's an example of the configuration for a Camel Kafka Elasticsearch sync connector with the enhancement for increased error tolerance. So basically, I've tried to configure it so that it will ignore all errors and send any errors to the dead letter queue. And it worked. So we've got now pretty good robust handling of HTTP errors, at least, and the connector keeps running when it encounters an HTTP error. I also tried this method to handle the Json error messages. I wasn't able to get that to work. I also tried correcting that on the Elasticsearch side. You can configure Elasticsearch to have essentially schema validation, or sort of a poor man's approach to schema validation, which sort of works. Elasticsearch picked up the fact that the JSON error message didn't look like a proper data message and failed, but unfortunately I couldn't configure the connector to ignore those failures, and it again went into the fail state and stopped running. So at this point, another opportunity arose. We were thinking of trying PostgreSQL as the sync and Apache Superset as the visualization tool. Apache Superset looked like an interesting alternative to Cabana, but only works with SQL databases as sources. PostgreSQL is an open source SQL database, and it was on our managed services roadmap and available to me as an internal preview at the time, so it was good timing. PostgreSQL has excellent JSON support as well. It's got something called a JSON-B column type, which allows indexed JSON binary format, and it allows for complex and fast JSON queries. So it seemed like a good match and worth exploring an alternative sort of architecture at that point. the question then was, where do we get an open source Kafka Connect PostgreSQL sync connector from? And the answer was, well, there was only actually one that I could find, which didn't work. And then I thought a bit more generally and thought, well, Postgres is a Jdbc compliant database. So what if I just look for some Jdbc connectors? And there were more potential Jdbc connectors available. So I did a bit of an evaluation of some of the better looking open source ones. Most of them assume that you've got an explicit schema as part of the payload. Most of them assume that you've got a simple flat JSON data object, and most of them assume that you want to insert elements into multiple columns on the database side. None of those things were what I wanted. So my solution, which was schemaless and enabled you to insert JSON into a JSON-B single column, was to hack an IBM Jdbc sync connector. It reads JSON Kafka record value. It creates a Postgres table with 2 columns, an auto-incrementing ID, and a JSON-B column with something called a GIN index, and inserts the JSON object into it correctly. So this allows for the example data, the example title data, which is structured JSON, and it worked quite well. It's also quite robust. Postgres natively rejects invalid JSON, and so it completely rejects HTTP being fed to it, and the system kept on running quite reliably. It can also be configured with constraints. For example, you can set a constraint to check if the JSON data has the right data and metadata fields. So that works pretty well. So Apache Superset was the next part of the puzzle. It's not something we actually offer as a managed service at this stage. So I had the question of how to deploy it. Well, it's easy enough after some messing around to deploy it in Docker on a laptop. How do you connect it to Postgres? Well, that was relatively easy. Postgres is actually used as the default metadata store for Superset. So all I had to do is sort of configure another store to my Postgres database that I was using. Can it access and chart JSON-B Postgres data types? Yes, by using something called virtual datasets. You use Postgres JSON-B operators, casts, and functions to create a virtual dataset with separate columns from the JSON data. So here's an example of constructing a virtual dataset for the example NOAA data. Took a while to work out how to do it and to debug it, but it did work correctly eventually. And I should say I'm not an SQL person, so to an SQL expert it's probably obvious, but wasn't to me. So in Superset there are lots and lots of visualization types. So I was particularly interested in seeing whether I could replicate the mapping types in Cabana. So this is an example using a map box, which does sort of location clustered data on a map. One of the things about Superset is it's got an SQL-free chart builder. So for normal usage, you really don't need to use any custom SQL like I had to for the virtual data set here. So once you've got the virtual data set up and running, you can just use the SQL-free chart builder, and that works pretty well. So there's an example of the map there, showing the location of the tidal data stations. You're sort of spoiled for choice with Superset. There are lots of visualization types, and it's quite difficult to choose one that's the correct one for your use case. There are lots of geospatial charts. A lot of them are examples of what's called deck.gl geospatial charts, which are quite powerful, but quite tricky to get working as you'd expect as well. So here's an example of a deck.gl scatter plot, where the size and color are basically sea level trends in millimeters a year. So this enabled me to sort of show, well, some locations on the planet are going to flood earlier than others, looking at trend data. So maybe not a good idea to buy real estate in those locations at this point in time. Scalability. So it's one of the more interesting things that I was interested in doing this experiment, how scalable is the whole system and the individual components as well. So also what to measure in terms of your ability to scale a system up. There's lots of potential dials and knobs that you can have on a system of this complexity, and lots of different systems as well. So this is sort of the summary of what I ended up with. I collected the relevant metrics with Prometheus from our Instaclustr monitoring API across multiple systems that were involved in the pipeline. So these are sort of the ones that I eventually concluded were the most relevant. So they include things like rate, counts, and latency and lag as well, in terms of how many events are still waiting to be processed as well. The trick with Prometheus and Grafana is that you can collect all the relevant metrics you want on one Grafana dashboard. So this was quite critical to be able to monitor the whole system end to end. There's a few actually missing off that screenshot, but the goal was to keep the lag down, the end-to-end lag down, while increasing the number of tasks with the connectors and the total throughput of the system. So how scalable was the final system? So this shows the relative size of the infrastructure for the two different approaches. On the left, you've got the Postgres and Superset system. On the right, the Elasticsearch system. So in common is the Kafka clusters, the Kafka Connect clusters, which are sort of the biggest part of the system, and then either Postgres or Elasticsearch as the target systems. So the price in terms of running this on AWS is pretty comparable. The number of nodes is pretty comparable as well. So my first attempt at getting some throughput results, this is focusing purely on inserts a second, shows that the Postgres system had a lot more capacity, surprisingly. I was getting about 42,000 inserts a second into Postgres versus only about 2,000 into Elasticsearch. So something strange was obviously going on at this point. So in a typical Mythbusters style, I basically made it work. So it's not really a fair apples to apples comparison at this point. It's more an apples to something strange like an orange or worse. So I managed to get them both at around 40,000 inserts a day, which is quite a lot of inserts. It's about 3.4 billion a day. So it's quite a high throughput system at this point. How did I do it? Well, I sort of cheated. I used an Elasticsearch Python client, and using the Elasticsearch bulk API actually as well turned out to be a critical thing that you really need to get high numbers of inserts into Elasticsearch. So yeah, so there's a few caveats in terms of doing this in production. Well, you really do need the bulk API, which currently I haven't got going in Kafka Connect. There's something funny going on the Postgres server. It's hitting 50% CPU and not being able to be pushed any higher. And in theory, Elasticsearch will scale horizontally with more nodes and shards added as well. But having said that, this was using the identical JSON data across both systems, and they used a similar size and cost for the clusters. So just some final conclusions. So first of all, looking at the common part of the infrastructure, which was Kafka Connect, it enabled heterogeneous source sync zero code integration of streaming JSON data, but there were some custom mappings and custom SQL required on the sync system side. It has good scalability and throughput. You need custom monitoring really to be able to scale the system reliably. To scale, you need to increase the number of connected tasks, Kafka petitions, and sync system resources as well, which is quite important. So you need to keep an eye on all of the systems end to end. The Kafka Connect cluster was the most resource-intensive part of the system, so you need to make sure it's got sufficient resources as you increase the load coming in to the system. Kafka's got two useful superpowers, which is the ability to buffer spiky loads and to replay data, because data is persistent, and read many because it's persisted in the topic logs. So that's quite useful. Open source Kafka connectors were of varying quality, functionality, robustness, and performance. You really need to evaluate and test with valid and invalid input data. And robustness is a function of the connectors and the sync systems taken together as well. Required a bit of hacking to work correctly with complex schemaless JSON data. And you need to test the performance and scalability before you go into production. Elasticsearch versus Postgres as the target sync system. Just a few sort of observations. The Kafka sync connectors worked, but you do need to have a bulk API version of them available, which I haven't found yet. I had to hack a connector to work for Postgres. The error handling was sort of comparable, slightly better for Postgres. Resources and cost, as I've said, was pretty comparable for both. Throughput, once I'd sort of made it work, was comparable. Horizontal scalability, in theory, is excellent with Elasticsearch. With Postgres, not so obvious, perhaps, how you'd scale a system bigger than you can with one server. And finally, Cabana versus Apache Superset. I guess Cabana, for me at least, was the easiest one to get running because we just provide it as a managed service. Superset was okay running as a Docker. There was some customization required on the Superset side. Superset has an awful lot of charts, including some quite powerful geospatial charts. Cabana only works with Elasticsearch. Superset will work with SQL databases and, in theory, I believe, with Elasticsearch, but I did not test that. So that's it from me. You can try us out if you want to build a similar pipeline or try building something even weirder yourself using the similar technologies. We've got a free trial available on our website. The GA for our managed Postgres came online in December, so that people have been using that now for a few months, and that seems to work pretty well so far. I'm quite impressed with Postgres. I'm new to Postgres. It's quite powerful in terms of the data types available, particularly some of the JSON features, but also some of the GIS features are quite impressive as well. Something new, one of our newest additions to our managed platform is something called Cadence from Uber. So it's the Uber open source workflow engine. I've been playing around with that and have written my first couple of blogs on it. It's focused on developers primarily. It doesn't have any visual tools for building workflows, but it looks like it has great potential for building data analytics and machine learning pipelines and workflows as well. It gives you a lot of control over things like time and error handling, and it's very, very scalable in the way that it's designed. It's quite clever. So check that out as well if you're interested in sort of a new technology for data engineering pipelines. Thanks very much. If you want to check out all my blogs, I think I've written about 80 blogs in the last 4 years. There's the URL that includes the 10-part pipeline series and the example configuration files in GitHub, and the latest Cadence blog, Spinning Your Workflows with Cadence. So thank you very much. That's all from me.
Awesome, Paul. Thanks so much. The questions on the channel have been a little bit quiet, but I think this presentation was like jam-packed full of awesome sort of exploration of various services, including a bit of the Instaclustr managed offering services, which is really good. I guess what are the key take-homes that we should take from your presentation? I guess what you were trying to do was do a bit of a comparison between the benefits of using certain technology versus others, perhaps Elasticsearch versus Postgres and Superset visualizations. Is there anything like when you're doing a technology evaluation, any tips that you can provide for folks to help them on their way to, I guess, get the optimal solution that they're looking for?
Yeah, it's an interesting question. I've done lots of technology evaluations over the years, so typically focusing on performance. So scalability and latency are ones that I like to try and measure at least, and then optimize for, and particularly when you're dealing with big data technologies like Kafka and Cassandra. you might just think, well, we just throw more resources at the cluster and you instantly get scalability and low latency. Well, it's not quite that straightforward. There's a lot of other knobs that need tweaking. In Kafka, particularly, you've got Kafka petitions or topic petitions that are actually a critical thing that you have to include when you're designing your model of your system, and also then as you're operating it, keep track of how many petitions you've got and make sure you've got enough, but not too many. Basically, is the rule of thumb for that. And yeah, the Kafka Connect experience was quite interesting. That was my first time trying Kafka Connect sort of in a production environment. It really does take some effort to test the available connectors and perhaps modify them for your requirements. But yeah, again, making sure you test them with some realistic data, which includes error data, is quite critical. Initially, I thought my system was up and running fine, and it was running for a few weeks before I started getting these errors coming through, and then it took me quite a while to work out what was going wrong and then how to fix them. So you want to do that before you put a system into production, I would imagine.
Fair enough. Yeah, it's really good tips. Jose Reyes has asked if you can, he said, thanks for your presentation, Paul. Can you please share your slides? So perhaps if you're comfortable with that, you can drop them in the share something channel on the Data Engineering Meetup. That'd be awesome if that's possible. And just real quickly from Srikanth Ramesh, hopefully I've pronounced his name correctly. Can you explain further about REST API source connector?
Okay, it's probably a bit of a magic one, actually. It may not be one that's commonly used, but there is an open source one. I can't remember which one I ended up using. I think there are a couple of options. Certainly in my blogs and the GitHub, I have listed which one I did use. Basically, you configure it, and it will go to a particular URL and get the data back in whatever format you've requested, and then put it into a Kafka topic, and then you can just use it in your downstream system. So it looks potentially quite useful for a lot of use cases. Again, one of the issues of getting data from like public data sources is knowing what format the data is actually, what it means. So often they are schemaless, whereas a lot of the Kafka ecosystem assumes that there is an explicit schema. So there's a bit of complication around that. Yep.
Yeah, nice. Plenty to explore, and you've given us plenty of food for thought in this presentation. So we thank you once again for coming along and sharing your hard-earned wisdom with the data engineering community once again. So
great. Thanks for the invite, and thanks for listening.
Yeah, looking forward to your next one. So catch you next time, Paul.
Okay, see ya.
Appreciate it. Awesome. Okay, now it's time for my AWS reInvent recap. I suppose I should probably just say a few words about myself. I've been organizing the data engineering meetup for probably about 5 years. And now we've got a whole team of organizers helping us all out, which is really awesome. I'm also an AWS serverless hero. At one point, when I was collecting lots of certs, I had around 7 AWS certifications. So, and really my passion is around serverless data engineering. And that was kind of a pretty big theme of this year's reInvent, last year's reInvent that happened about a month ago. So I'm pretty excited actually to go through this reInvent recap with you to sort of take you through some of the amazing, announcements that occurred. So without further ado, I'll just share my screen and start sort of taking you through all of that. So hopefully you can all see that nice and easily. Okay, cool. So on to the AWS reInvent recap. Basically, the quick little bit of background is on the slides that I'll be taking you through, if there's no sort of tagline at the bottom that says preview or GA, which stands for generally available, it means that it's just an announcement. So the preview and general availability will be coming in a little while, but I'll probably just kind of let you know as I go through the slides which one's which. And I just wanted to reiterate, This is just a selection of the reInvent announcements. It's not everything. I've just kind of handpicked the ones relevant to a data engineering audience to save us from being here for hours and hours. Awesome. So the agenda today, I'm going to take you through the first up, the Dev and DevOps section, then the serverless section, because a lot of data engineering is serverless these days. Then, analytics, because data engineering is a big part of supporting analytics. And then last but not least, we'll go through databases. Okay, so without further ado, let's dive into developer and DevOps. So first up, we've got this new feature called Amazon Code Guru Reviewer, which is generally available. It now detects hard-coded secrets in Java and Python. So just in case you've accidentally perhaps left a database password in your code, this will basically detect that for you, which is pretty awesome. There's also the AWS CDK version 2 that's been released. This says it's in preview, but it's mostly fully operational. Basically, it means that it allows you to just use a single AWS CDK lib rather than sort of importing, 50 million libraries, one for each service. Now, I'm pretty sure AWS must be up to its 50 millionth service by now. Experimental modules are distributed separately, though. That's one thing to note. And it's also got the new CDK Watch functionality. There's also the AWS CDK construct hub. I had a typo there. Basically, what this does is allows you to share open source construct libraries with the wider cloud development community. So that could be something that you might be interested in, and that's also generally available. Another one for those of you who are doing a lot of Docker-based workloads, especially in regulated environments where you need to make sure that you're operating just solely within a VPC without internet access. There's Amazon ECR pull-through cache repositories. This basically allows you to access public container registries through ECR, without needing authentication, and you just use that via private link, etc. So that's generally available. Another really cool feature is a new community Q&A site. You can get answers from AWS and customers on AWS relevant questions that you might have, and it's expert reviewed. So feel free to go ahead and sign up for that one. That's now generally available, and it's also free, which is awesome. Okay, that's the dev and DevOps announcements. On to my favorite section, which is the serverless announcements. So first up, we've got AWS Lambda event filtering. So what this means is you can filter incoming events before function invocation. It's got the same pattern matching rules as Amazon Eventbridge. You can divide up to 5 patterns per event source mapping, up to 2,048 characters each. And then batching is applied after filtering. So if we go across to the right here, where we've got a CloudFormation YAML snippet, and you can see the function name and the batch size of 100, and the event source ARN, which is a Kinesis stream, and it's got a filter pattern of tire pressure numeric values of less than 32. It's the 100 records with a tire pressure of less than 32, as opposed to the 100 records of all the potential tire pressures. So that's really cool. Basically, the end result is you get reduced traffic to your function, which therefore means reduced costs. And it's got support for Kinesis starter streams, Dynamodb streams, and SQS, and it's generally available. General availability is a big feature of the serverless announcements, which is pretty amazing. Super awesome to see. Another Lambda one is partial batch response for SQS. So basically, you can process information at record level instead of batch level. You've got partial batch response features. An SQS queue will only retain those records which could not be successfully processed. What that does is it improves processing performance, and removes the need of repetitive data transfer, increasing throughput and making SQS message queue processing more efficient. And so that's available for both standard and FIFO SQS queues. Cool. So another one, this is probably my favorite announcement, in fact, is Amazon Eventbridge S3 data plane notifications. So this allows you to easily build and deploy event-driven applications without the need for custom software. You can act on new data in S3 faster, make changes to event-driven applications without interruptions, and debug by replaying past events. And you only pay for events that match a rule. So this is generally available. The old pattern used to be, I think you needed to go through CloudTrail, and there was a bit of a lag before it hit Eventbridge. This one's much more direct, so you're going to see far lower latency. You can apply it to any bucket, and of course, you can you can apply an event pattern based on certain event types like object created, object deleted, and the like, or you can specify a specific bucket. So that is super exciting. And then another one is for event sources is the AWS offset lag for MSK and self-managed Kafka. You'll recall that Lambda announced support for MSK and self-managed Kafka as event sources. And effectively what this means is, you've got this new metric offset lag to monitor the performance of MSK and self-managed Kafka. The offset lag is a metric, is a measure of the total number of messages waiting in the message queue to be sent to the target Lambda function. Just basically provides transparency into the amount of data congestion in a message queue, and you can quickly diagnose and solve inefficiencies in the data stream. And then also MSK provides a whole bunch of extra consumer lag metrics as well. So that's all generally available. A pre-announcement for Lambda, which is ephemeral storage. So you can provision between 0.5 gig and 10 gig of ephemeral storage in the temp folder, provision it in 1 megabyte increments, and it's available for both zip and container packaging. Customers are charged for storage provision by beyond 512 megabytes. If you just keep it the same, no additional charges applied, and storage is encrypted with an AWS managed key. So that's really cool to see. And then also Amazon Eventbridge cross-region support. So if you've got a multi-region business, or you've deployed to multiple regions, you can sort of consolidate all of those Eventbridge buses into a single Eventbridge bus, for auditing and monitoring purposes or whatever you need it for. So that is super cool. And then there's also for AWS step functions, there's integration with the Athena console. So sometimes when you're using Athena, you'd like to use it as part of a workflow. This allows you to, view interactive diagrams of workflows that incorporate Athena, launch sample projects, and just basically generally manage step function workflows from the Athena console. That's generally available, which is awesome. So that's kind of a little bit like a mini Airflow sort of setup, I guess. And then another one on AWS step functions is Sync Express support for private link. So this is generally available. It allows you to start synchronous express workflows from VPC via private link without traversing the public internet. Great for SDK integrations. All you need to do is create a new VPC endpoint, but no other changes required. Keep the security folks happy. Amazon SQS dead letter queue redrive. So you can efficiently manage lifecycle of unconsumed messages in dead letter queues, standard queues only. You can redrive the messages from the dead letter queue to source queue, examine unconsumed messages, and recover from errors and reprocess messages. Allows you to easily inspect a sample of messages in dead loaded queue and then move to source queue and avoid custom reprocessing scripts. And then with another one for Amazon SQS is managed server-side encryption. Again, to keep the security folks happy, you can protect your sensitive data with SQS owned encryption keys, and as well as KMS. So just allows you to reduce the operational burden and complexity in protecting data, alleviates the need for the customer to create or manage their own keys. Awesome. That's all the incredible serverless announcements. Let's dive straight into the analytics announcements. So first up, we've got Data Exchange for APIs. It's a RESTful or GraphQL API that you can call directly to AWS Data Exchange. You can use the SDK in the programming language of your choice. It helps you manage API access centrally with AWS IAM. And so that's generally available. Lake Formation Govern Tables. So this is a new storage API to simplify how data is ingested, stored, and managed together with row-level security to protect your data. So it's granular access control at row and cell level access policies, govern tables that allows you to ingest, manage data at scale easily and reliably, and then also storage optimization. So it helps you with automatic table compaction, to improve query performance, and that's generally available. Amazon Athena ACID transactions preview. So this is built on the Apache Iceberg table format. You can write, delete, update, and time travel, and then enables concurrent users to make row-level modifications to Amazon S3 data, and you get to use Athena's console API, ODBC, and Jdbc drivers with it. So can't wait for that to go GA. One that is GA is the Athena engine upgrade. Allows you to do queries up to 3 times faster and up to 70% cost savings, which is incredible. The new storage API that we just mentioned previously, that's GA. This just provides you another bit of a slide of all of the features that are available through there. Awesome. A huge one. This is an announcement. It's not a preview or generally available, just an announcement, but EMR serverless, which just is going to be super, super awesome. So it's simple to use, easy to run, petabyte scale data analytics in the cloud without managing, tuning, optimizing, securing, and operating clusters. It's fast and highly available, highly scalable, and cost effective because it's serverless. You only pay for the resources you use for data analytics at scale, which is just amazing. Also, MSK serverless. This is a preview. So it allows you to easily run Apache Kafka clusters without right-sizing cluster capacity. Instantly scale I/O without worrying about scaling capacity up and down or reassigning partitions. And then you're paying for the data volume you stream and retain. One generally available announcement is Kinesis data streams on demand. This isn't such a serverless service in that it sort of scales to zero, but it's probably the next best thing, and it looks like it'll be fully serverless eventually. But it's it just simplifies streaming data processing by eliminating capacity management, flexible scaling, automatic high availability, and you can just lower your cost by paying for per gigabyte of data written, read, and stored. Awesome. There's also this really awesome new program that's just come to Australia called Aws Starter Labs. They will do a bunch of really great things for you, which is to they do a build lab and a design lab with you. It's a bunch of AWS solutions architects that are helping you out. Oh, my screen is all gone all wonky, but hopefully we can fix that up on the next slide. I will just try to fix this up. 1 second, folks. Okie dokie. Let's press play from here. Okay, so anyway, that was AWS Starter Labs. Reach out to your local solutions architecture team at AWS or your account manager to give that a go if you're interested. So yeah, local team of data engineers, got a build lab and a design lab. Awesome. So that's the analytics announcements. Let's get on to databases. Amazon RDS Custom. So some of you folks, a lot of folks have mentioned that, how awesome Amazon RDS is, but they want to have access to the underlying operating system to, install, third-party custom software and stuff like that. So that basically is what RDS Custom is. It's available for Oracle and SQL Server, you still get all the awesome benefits of automation that RDS provides, and that's generally available. Of course. Gosh, my computer is saying no at the moment. Hopefully, apologies for all of this. Okay, onto Amazon DevOps Guru for RDS. Another feature that's gone generally available. It's basically an ML-powered database advisor for Amazon RDS. First release for Amazon Aurora, if you're familiar with that. Basically automatically detects and diagnoses hard to find performance bottlenecks and operational issues. It's based off like all of the ML models informed by years of operating thousands of databases for Amazon.com. No ML experience required, and it just continuously monitors your database workloads at scale. That's generally available. Amazon Dynamodb standard infrequent access tier. This is generally available. Basically, the whole idea is it lowers your storage costs, no performance trade-offs, and no developer overhead. So this is really if you've got an absolute ton of data in DynamoDB that's very infrequently accessed, but you just need it available there. This will help you to save a bit of money on cost with DynamoDB. Okay, there's also a slide on what's new in Amazon Timestream, which is the real-time, just about how real-time analytics orders of magnitude faster and cheaper with it. There's multi-measure records, so you're able to stack multiple records into a single table row instead of one measure per table row. You can schedule your queries now to improve query performance and reduce costs. And then there's also magnetic store writes. So, it's a flexible and cost-effective solution for late arriving data. Another amazing announcement is Amazon Redshift Serverless. This is a preview, can't wait for it to become generally available. But really what it's all about is it automatically provisions and scales data warehouse capacity, means you've got faster time to market, don't need to worry about data warehouse management. You pay for what you use, automatic scaling, compute provisioning, automated patching, failover monitoring, backup and recovery, routine maintenance, and security and industry compliance. This is another slide of kind of how it all sort of hangs together. If you're it's got an easy startup experience. If you're a developer or a business analyst, you just use, just activate Amazon Redshift Serverless for your AWS account, connect your favorite BI tool, or use the Amazon Redshift query editor, load a bunch of data into it, and then just pay for compute and storage use during analysis, which is amazing. Then, of course, we've got Redshift materialized views, auto refresh, and query rewrite. Effectively, this is a preview, but the TLDR on this announcement is that it's, what it does is it allows you to massively reduce, say the customer example here, reduce dashboard load times from 8 minutes to just 500 milliseconds. So, that's just provides a really incredible end user experience for those particular workloads. There's also the Redshift query editor version 2, which includes notebook support. Got a bit of a data group vibe to it, but you can organize all your queries by saving them together into a folder, and share with your teammates and do a whole bunch of stuff there. It's a preview, but again, can't wait for that to go generally available. Another one, maybe for the consultants among you, there's AWS Database Migration Services Fleet Advisor. You get to accelerate database and analytics migrations with automated inventory and migration recommendations. So this is a preview. It allows you to automatically gather database fleet information, generates a list of possible migration targets, results in hours instead of weeks and months, which is really good. Again, on DMS, there's time travel that's being announced as generally available. You can store and encrypt AWS DMS logs using Amazon S3 and view and download and obfuscate the logs within a certain time frame. Log and debug replication tasks, and time travel can be used in all AWS regions with DMS-supported PostgreSQL source endpoints and DMS-supported PostgreSQL and MySQL target endpoints. So that's it from me. Massive thank you to you all for hanging around and listening. I will stop my screen share and just let you know that basically we're always on the lookout for more speakers. So if you want to come along and tune in next time and perhaps even present a really cool data engineering topic, then you are absolutely most welcome. So thanks once again, and ciao for now. Bye.